Recording. Okay, what's the last class? What is our last class?
Operators.
Operators, right? So from the operators, we done the almost 5 operators. We have only one more operator, which is the bitwise operator, right? So when you want to work with bitwise operators, to make sure that you have to so you know how we can convert the decimal number to binary number, as well as you should know how we can convert the binary to decimal as well. Okay, then only this particular concept will help you. I mean, it can be easy to understand, otherwise it's a little tricky to understand. Okay. Prasad, can you call to the Kishore and Suman? Just one second. So fine, let's go to our specific folder where we are working, and we are working in the membership folder, and let's create the new file. The name of the file is what? It's today's date and the corresponding topic, so which is the Python bitwise operators. Okay, so however, my first primary thing is that you have to know the mathematical thing behind the bitwise operators. Okay, so basically bitwise operators are working on the bits, not on the data. So whatever the data we have it, so the data it might having it has to be converted into the binary, then only it will work on that particular binary data. For example, so if I have a data, whatever the data we have it, that it would be the number. Okay, so this particular number you have to be converted into the binary number. You have to be converting into the binary number. Clear? So then only we can do the operation on that particular data. So directly it is not possible to do the operation on the data. First, whatever the data we have it, that particular data you have to be converted into the binary. Then after we have to do the operation on the binary data. There we are getting some kind of result. The result, which is the binary result, again that particular binary result you should be converting into the decimal format. Okay, is it clear my point? So whatever the data we have it, the data first of all you should converting into the binary, then do the operation on the data, then after we will get the some kind of binary result. That result we should be converting into the decimal format. Clear? Let's take some example. I have a number is, for example, 40. Okay, I have a number is 40. So this is the 40. It's a decimal number. I want to be converting into the binary. How it is possible? It is simply you can do the division with 2 or LCM with 2. Okay, 220 just it's a 40, right? So you just need to collect the remainders for every situation. Okay, for every possible outcome. So you're collecting the remainders here. So next you can division with 2. 2 10 just 20, right? So here also the remainder is 0. Next one is, so 2 5 is how much? It's a 10 only, right? Again reminder it could be the 0. And this is the way you can do the LCM until unless you're getting the coefficient is becomes 0. 2 2 just 4, right? So 5 minus 4 it's a 1. So remainder is 1. Next we can do the 1 time. So 2 1 just 2, right? Remainder is 0. So next we can division with 2, 0 times, then it's a 0, 2 minus 1 minus 0, it could be the 1. So until unless the coefficient is becomes 0, we just need to do this particular operation, and we have to collect this particular binary bits. So here we have to write in such a format. Okay, so right to left, 0 0 0 and then 1 0 1. So this particular format you should write it. Okay, Is it clear my point? So these are the bits. This is the binary number for the 14. Okay. So why I'm explaining this one, because of internally the Python which is working on the binary data only. So why we are getting the result and everything, if you want understood, so you should know how we can able to convert the decimal number to binary number as well as binary number to decimal number. Let me consider I have a number is 1011011010. Okay, this is my number. Okay, so this is my number. This is the binary number. I want to be converting into the decimal number. Okay, so how it is possible? So it's a very simple thing. So every how we have to do it, this thing very simple actually. So every positional bit, it's a zero position. This is one position. This is two position. This is three position. This is fourth position. This is fifth position, and this is sixth. This is seven. This is eight. This is ninth position. Okay, so what you should do, every bit you have to multiply with, okay, every bit we have to multiply with the corresponding 2 power of the position. So 1 into 2 power of 0. Okay, then we have to do the sum. Then this is the 1, right? This is the 0, the 0, right? 0 into 2 power of 1 plus this is 1, right? So 1 into the corresponding position is how much? It's a 2. 2 power of 2. Next, 0 into, and 2 power of the position is what? It's a 3. So every time the bit which is multiplied with power of the 2 power of the bit position, bit into 2 power of bit position. So simply you can say sum of equal to 0 to n. So the bit, so each and every bit I into 2 power of I. Okay, it's a formula for that. Okay, so now so 0 into 2 power of 3, next 1 into 2 power of 4, and plus then 0 into 2 power of 5, and so on. We have to be write it. Okay, so tell me what is the value. So 1 into 2 power of 9, so 0 into something, it's 0 only, right? So next one is 1 into 2 power of 7, next 1 into 2 power of 6. So fourth bit position is also, it's a 1 only, right? So 2 power of 4, next. So 2 position also, it's a 2 only, right? 2 power of 2. Next, first bit position is a 1, right? So 2 power of 0. So what is the value of 2 power of 9? What is the value of 2 power of 7? What is the value of 2 power of 6? What is the value of 2 power of 7? 2 power of 2. 2 power of 0. 2 power of 0 is a 1. 2 power of 2 is 4. 2 power of 4 is a 16. And 2 power of 6, it's a 128. Is it 128? A 64? It's a 64. Okay, 2 power of 6 is 64. 2 power of 7, it could be the 128. Next, 2 power of 8 is 256. 2 power of 9 is 512. Is it clear? 512 plus 128 plus 64 plus 16 plus 4 plus 1. So when you sum of this all thing, then that could be the resultant of the decimal number for this corresponding binary number. You just remember, guys. So this is the format only. So if you have a binary, if you have a decimal number, to converting it to the decimal, just do the division. When we have a binary number, when you want to convert into the decimal, then you should do the multiplication of each and every bit and corresponding bit position, and then we can do the sum, right? So you just need to remember these things. But but in Python we have a built-in functions to convert the binary to decimal and as well as decimal to binary. For example, I have a number is 14. So this is the number I want to be converting into the binary number. Simply we can use the bin of that particular number you can provide, then which is giving the corresponding binary number for the, so corresponding so you'll be getting the binary number for corresponding this particular number, right? For example, I have a binary number. The binary number is, for example, so you can representing with 0b. Okay, so 0b and 1011010101 something. Okay, so we have number something like this. So this is the number I want to be converting into the decimal number. We can have a function is bin function, and we can provide the number, binary number. Then we have to provide the base number. So binary number base is 2, so that we just get the output is 2901. sorry, 2901. So 2901 is the decimal number for corresponding this particular binary number. So 101 double 000, it's my binary number corresponding this particular decimal number. So this is the way we have some kind of functions are there to understand the binary numbers and decimal numbers to get the result of binary numbers and decimal number. But the process is whatever I explained previously, that exactly the process. Okay, clear? Is this clear? So hello guys, is it clear or not?
Yes.
Okay. Now you just look for so bitwise operators, right? When comes to the bitwise operators, which is, you already know that, which is operating on the bits, okay. So we have these 6 operators are there: bitwise AND operator, and next one is bitwise OR operator, and third one is bitwise XOR operator, okay, and the fourth one is bitwise left shift operator, okay, and the fifth one is bitwise right shift operator, okay, and the last but not least, which is the bitwise not operator. So each and every operator which is having corresponding symbol. So not AND operation symbol is ampersand, okay, OR operation symbol is pipe symbol, and XOR operator symbol is cap symbol, and left shift is two less than symbols, we can use it. So greater than, right shift in the sense to, you just use the two less greater than symbols. Not operator is, it's a negation symbol, okay. So these are the symbols or the bitwise operations, bitwise operators actually, okay. Now let's do a small example. I have a number, the number is 45 under operation with, for example, a 40. So now what, tell me what is the value of the resultant of 45 and 40. So instead of this one, you just go through a number is, for example, 34. So we are getting 32, right? Okay. So different values we can consider, and why we are getting this one, let me explain now. And 32, 23, we are getting 3, right? So there is no why. So usually AND operator means, logical AND operator means either we are getting the input 1, either input 2, right? But when comes to the bitwise operator, which is not like that, don't confuse yourself. Bitwise AND is different, logical AND is different. Bitwise AND is working on the bit, logical AND which is working on the number or input, okay, directly on input. So let's look this particular example. So I already told you, right? So first, whatever the number we have it, that particular numbers, it can be converting into the, whatever the number we have it, that it can be converting into the, okay, binary number. So print of bin of 45, and meanwhile we can try to convert the binary number for the 34. So if you want to convert it mathematically, I already explained that one, but for directly looking into that particular numbers, we can use we can use bin function here, okay. Now when you are converted, so what happens internally, I'm trying to explaining now. So this is the 45 internally, which is converting into the binary, and next one is 34, the 34 which is converting into the binary, that's fine. After that one, you are doing the AND operation, right? So what is mean that AND operator? If and only if both inputs are same, then output, I mean, if the both inputs are 1, then only output is 1, otherwise it could be the 0. So I just do the AND operation on bitwise. 1 and with 0, 0, 0 and with 1, 0, 1 and with 0, 0, and 1 and with 0, 0, 0 and with 1, 0, and 1 and with 1, it's a 1, right? So this is my binary number, okay. 1000000 is my binary number. So you already know that how we can able to convert binary number to decimal number. You can use mathematical notation, or else directly we can use the function over here, okay. The function is 0b and 1000000, right? So this is the base is 2. If I'm giving the 2 is, if I'm giving the base is 2, then which is converting into the 32 or not? Is it clear? So this is the result of 0b 100 000, which is the result of the bitwise AND operator for the 45 and 34. That particular binary number, automatically Python is converting it to the decimal, so that we are getting the result is 32 here. Clear? Is this clear or not?
Yes.
Any questions?
No, sir.
Okay. Now, meanwhile, we can look for this 67 and 23. So we can try for the bin of 67, right? 67. Meanwhile, we can try to convert bin of 23, right?
Sorry to interrupt.
Yep.
I guess I have the same question as Ganesh is having. He's asking, like, what is the use of this in the real world?
So so when you want to do the operation directly on the bit, then the speed can be increased. Usually these bitwise operators, data science guys are not using, but who are working on the low levels applications, like when you want to develop some kind of drivers, okay, or else if you want to implement some kind of OS related applications, okay, then if you want to do some kind of operations a little bit speed, then we can use the bitwise operators. Clear?
Like you were using some kind of like
Yes.
machine
Yes,
language?
it's not mission language. It's like algorithms. Simply we are
Got
going to building some kind of mission level algorithms.
you. Got you.
Okay.
Like you are storing numbers into transistors and stuff like
Yep,
that, right?
that's correct.
Okay, thanks.
So 23, so bin of 23. So here we are getting the, so here see the corresponding bits, first bit and first bit. So you have to apply the AND operation on the first bit and first bit. So here first two bits are 1, right? So resultant will be 1, and next two bits also, this bit and this bit is 1, okay, and so this bit and this bit is 0 and 1, so it's a 0. Next one is 0 and 0, it's a 0. Next one and with 0, it's a 0 only. Rest of the things automatically it can be considering as a 0, so automatically you will be getting 0 only. So double 1 in the sense it's a 2 power of 0, 2 power of 1, right? So 2 power of 1 is 2, 2 power of 0 is 1, so 2 plus 1 it's a 3, so resultant will be it's a 3 only. Clear? So that we are getting the output is here 3. I hope you clear my point. Any questions? Now let's do the OR operation. When we are doing the OR operation, it's same like a logical OR operation only, but it is working on the bit level. So again, you already know the binary number for the 45. What is the value of the binary number for the 45? The binary number for the 45 is the 101101, and next 34 is 1001010. So when you are doing the OR operation, if at least one bit is 1, then automatically resultant will be 1, right? So 1 OR with 1, 1 OR with 0, 1, 0 OR with 1, 1, 1 OR with 0, 1, 1 OR with 1, 1 OR with 0, 1, 0 OR with 0, 0, 1 OR with 1, 1, right? So 1 0 double 1 double 1. So this is the number. If you are converting into the decimal number, then we are getting the resultant will be what it is, 47. Okay. Meanwhile 67 and 67 or with 23 also same thing, you will be getting actually. So each and every bit of the 67 and each and every bit of 23 bits, then we are doing the we are applying the OR operation on the bit level, then we are getting the some kind of binary number, then we are converting into the decimal, then we are getting the 87 here. Clear? Is there any questions? Is there any questions? What happened, guys? Did you got or not? Bitwise XOR means if both inputs are same, then resultant will be 0. If both inputs are same, then resultant will be it's a 0. If at least one bit is 0 or at least one bit is 1, or at least if the both bits are different, then it could be the 1. Okay, either first bit or second bit, whatever it is, both bits are different, then you will be getting the resultant will be 1. Okay, this is the truth table for the bitwise XOR operation. This is the truth table for the bitwise XOR operation. And for example, just go for the you just apply the XOR operation 45 XOR and 45. Okay, so here we are getting the 15 and 84. How you are getting the 15 and how you are getting the and so 34 will look now. So my binary number 45, I have to get it from the bin function. Meanwhile, I just get the binary for the 34. Then I just apply the XOR operation. You already know the truth table. The truth table is if both bits are the same, then output is 0. But here both are different, so here 1. Here both are different, here 1. If both are different, here also 1. Both are different, here is also 1. But here both are same, right? So that it's a 0. Here both are same, right? So that here is also 0 only. So this is my binary number. This is the binary number. If I'm converting into the decimal, definitely you're getting the 15 only. Clear? Meanwhile, we can do yourself 67 versus 23. You just convert the 67 into the binary. 23 also can be converting into the binary and apply the XOR operation on the bit level. Then you will be getting the some kind of binary result. That result you can try to converting into the decimal. Then you're getting the that specific result only. And that means 84 only. Clear? Guys, is there any questions? Till now, I just explained only bitwise and bitwise or bitwise XOR. Now, so bitwise left shift, the standard procedure is different, but I just want to give you direct formula for you. You just remember this one. Whenever a number you can converting into the binary left shift, you want to just shift towards left side some number of bit positions. Okay, some number of bits I want to shift towards left side. This situation, the resultant will be what happens here. The number it can be multiplied with number of 2 power of, okay, 2. We just remember this particular formula. Number it can be multiplied with number of bits, 2 power of number of bits. This is the formula, you can remember it, guys. For example, you have a number is 3. I want to shift towards 4 times. Okay, so what is the number we are getting? It's a 48, right? How you are getting the 48? Let's look now. 3 into 2 power means what? 2 stars we can use, right? 2 power of, is it 48 or not? 3 into 2 power of 3. So this means 3, you're doing the left shift of 4. That means 3 into, that means 3 left shift of 4 in the sense. That means 3 is multiplied with self, multiplied with 2 power of the number of bits. Okay, you just remember this particular formula. It can help you why we are getting this particular value. Okay, so for better understanding, for how bitwise operation or bitwise left shift is working, for understanding purpose, I just go through the bit level. So for example, whatever the number I have it's my 3. So that's 3 means 0 0 0 0 0. For example, my computer is 64 bit. Then you have to okay, so here my number is 3, right? 3 means double 1. For example, my computer is 64 bit, then 62 zeros automatically it can be set itself. Okay, now what I want to do, that I want to shift the towards left side. That means whatever the bits we have it at left side, that all numbers it can be removed once. It can be removed the last 4 bits, and moreover, how many bits you removed, that many bits you should add at right side. Okay, now you just convert the 110000, whatever the number you have it, this particular number you can converting into the decimal, then you will be getting the 48 only. This is Excel procedure actually. Okay, whatever the number you have it, that it can be converting into the binary. Then how many bits you want to shift towards left side, then simply you just remove the last that many bits, and you just add the how many bits you removed, that number of zeros you should add at right side. So then resultant you have to be converting to the decimal, then you will be getting the corresponding number only. Clear? So it's very little tough to understand, and I mean to remember everything. That's the reason you can have a standard formula. The number it can be multiplied with 2 into, okay, and 2 power of that particular number into 2 power of the number of bits you are shifting. Clear? You just remember this particular formula, you'll be getting this particular results only. Clear, right? So meanwhile, we can have the right shift operator, bitwise right shift. When right shift operator is working, so the number, whatever the number you have it, that particular number you should shift towards the right side. Okay, so how many bits you want to shift towards the right side, you just mention a number here. So the formula for this one is that number, you can use the floor division of 2 power of 2 power of number of bits. Okay, 2 power of number of bits. This is the formula, you just need to remember it. Okay, so left shift is the multiplication, right shift is the division. So for example, I have a number is 56. I want to shift towards 3 times, so which means you are getting the 7 only, right? So how you are getting the 7? Directly we can apply the formula, or else we can go through the process. So 56 floor division with 2 power of 3, then we are getting the 7 or not. So this is the formula will help you to directly get the number, or to directly get the result. But you know, the standard procedure is it's a different again. The standard procedure is whatever the number you have it, that you need to be converting into the binary. So binary number is 32 plus 16, how much? It's a 48 only, right? 48, 32 plus, yes, this is the my number, binary number for the 56. Okay, the 56 first you should converting into the binary number. Once if you are converting into the binary number, then what I want to do, that I want to shift to the right side, right? That means you have to remove the right side bit. How many bits you want to remove? 3 bits, right? If you remove these 3 bits, then what could be the resultant? Okay, it's a 111 is the result. So 11 triple ones, if you are converting into the decimal, then it could be the 7 only. This is 2 power of 0, this is 2 power of 1, this is 2 power of 2. 2 power of 2 is 4, and 4 plus 2 6, 6 plus 1 it's 7. So the resultant will be it's a 7 only, right? Clear? So this is the process. Either you can remember the process, either you can remember the formula as well. Now last but not least, which is the bitwise not operator. So bitwise not operator, we can use the negation and we can use the number. Number can be positive number, number can be negative number, whatever it is. Simply what you should do, n minus of number plus 1. Okay, negation of number means which means minus of number plus 1. Okay, for example, if I go ahead with the negation of 34, so minus of 34 plus 1, how much? It's a 35, right? Minus 35. Let me try this thing. So negation of minus 45. Negation of minus 45 means minus of number place, it's a minus 45, right? So minus 45 plus 1. So minus 45 plus 1, how much? Minus 45 plus 1, how much? Minus 44. Minus into minus, it's a plus 44, right? So that we are getting here plus 44. Is this clear or not? You have to remember
Yes.
these formulas. If you remember these formulas, it could be easy to understand. And I think who are working in the bit embedded systems, if who want to go as like embedded engineers or else Linux drivers, okay, or Linux developers, that kind of guys, they have to understand this kind of concepts actually. But who want to go as a like data science or data analytics, that guys, they we don't need this kind of concepts actually. Okay. So this is about bitwise operators from the Python programming language. So I hope you clear all the operators. If and only if you understood thoroughly the operators concepts, the next concept is control statements. The control statements class I would like to start by tomorrow's session. So tomorrow's session is pretty important. Pretty important. Don't miss it, anyone. Okay. So come to the class in a time, Sunny.
Yeah,
You are
yes,
20
Sanju.
to 30 minutes or late. Actually, I
Yes,
don't have the international balance, so that I couldn't make a call, but I put a message that you not received it.
yeah, yeah. Yes, I'm sorry.
Yep. That's for today's class, guys, and we'll catch
So
up tomorrow.
we don't
Regarding
have
about
class over the weekend, right?
sorry,
We don't have a class over the weekends, right?
weekends we don't have any class.
Okay. Okay.
EST or CST formats. Okay, so some guys from the India, so those guys they have a class Saturday, but they don't have a class in Monday.
Okay.
So the classes could be on a weekdays, Monday to Friday, as for CST or EST time format, time zones, or PST, not IST format. Okay, is this clear? Everyone?
Yes. Thanks.
Okay,
Yes.
that means we have a session tomorrow,
Yes.
or else take break. We will continue the classes from the Monday. So control statements are pretty easy, and we can flow continuously. Then we can directly start on Monday. Okay, tomorrow and day after tomorrow, and next 3 days we don't have any sessions regarding about this kind of sessions, because of control statements are it's a continuous classes we require. Okay, if I started and again if I give the 2 days of break, it's no use at all. Okay, so that Monday I can start freshly on control statements. Okay, so maybe it will take 3 to 4 classes to understanding the control statements. Clear?
So tomorrow we don't have a class,
Tomorrow
right?
we don't have a session, but usually we have a session tomorrow, but
Okay.
unfortunately I'm not even I'm also free, but so control statements are we require the continuous sessions, so that's the reason we can meet on a Monday. Okay.
Okay.
Yep. Bye guys, see you, take care.
Yeah. Bye.
Take care.